Um, I think they're setting up for that career fair, which is here the next couple of days, apparently, in the hall. So it might get a little bit noisy while they're doing that, but that's okay. Today we're just prepping for the test on Monday. So Monday, our big first test. And so that is when your algebra review must be finished, and this quiz, if you want, these are optional, so these are extra credit. If you want to turn that in, will be due. When I first put the settings on that one, I changed the settings to how I had intended quiz settings to be, which is when you submitted the quiz, you had to submit the whole quiz. But that was, so you couldn't just do one problem at a time. But that was a little bit disconcerting to some people because they're used to submitting one problem at a time and checking it. So since this is just extra credit, I went ahead and relented and put the settings back. So you can, on that one, submit one question at a time to check your work there. Forgot what I was going to say there. Submit one problem at a time, anyway, to check your work on that particular quiz. I think my battery here is giving out on me. So, and then I moved back here this homework 2.2 slightly till today. There was one or two problems in there. Well, one problem in particular that is really we didn't do exactly an example like that, and it's kind of difficult to read the graph, although you can read the graph if you're careful and if you squint a lot. And but I wanted to show you that the solution that's given to the problem in the homework hints is really way more complicated than we need, okay? And then we're going to look at some of the problems from the practice exam today, so I hope you brought a copy of that with you. John has a few copies, okay, that he can share, but I didn't make enough copies for everyone. So remember, this is on the Blackboard page, okay, posted under the sample test link. So definitely something you want to look at prior to the exam on Monday. Okay, so we're going to go over a few of the highlights there of the practice test. This practice test is longer than the exam, so and that's noted there on the posting there for the practice test. So don't think this is what the sample test, what the test length is going to look like. Okay, this is longer than the test. All right, and don't forget. So the test will be designed to fit into the normal class time. Don't forget to bring with you a calculator. You do not. I won't be able to use your cell phone as a calculator, and an index card. Right, you can use an index card. Write down what you want to on the index card, right, on Monday, okay? So don't forget those two things. So I'm going to go over some of the key problems here, but not the whole thing. But I do have the answers made out, so after class I will post the answers, okay, to the practice test. However, do the test without looking at the answers. So you want to use this as a genuine practice, okay? So try doing it without looking at the answers, and then after you've given it your best shot, go back and look at the answers, because if you're, flipping through the answers while you're doing the practice test, then you're going to say, oh yeah, sure, I know how to do that, right? Okay? And that gives you false confidence, all right, as to how you're actually going to handle such a problem when you see it on the exam, okay? And John will have a copy of the answer, so I guess during the tutorial session after class, I'll give him my answer sheet, so he'll have the quote-unquote official answer sheet. I hope they're all correct. Sometimes I make mistakes too. Okay, so especially when I'm in a hurry. But he'll have that, and So y'all can use that also in the tutorial session to prepare for the test on Monday. So you got lots of preparation. All right, let's get on with it so we don't waste too much time with me here just bloviating. And I want to look at first at 2.2, problem number 8 and 10, because those are two that we haven't done too much with. Okay. So there's not a problem like this on the exactly like this on the practice test. This is just a homework problem, but nevertheless, okay. And it's pretty easy, but really it is actually pretty easy. But what's difficult about it sort of is the fact that it's all just stated here textually, so you're not shown a picture. So it'd be better if you saw a picture. If you saw a picture, I think it would make it a little bit more suggestive, but it's not. So you just have to sort of imagine a picture of this in your mind. So it says you have a function named h, okay, and it's graphed, and you've got a tangent line to the graph drawn at the point -2, 7, okay? So apparently that function h goes through the point -2, 7 when you make the graph. What that means is, and this is really important, okay, is that h of 2 is equal to -7. Was that the point? Yeah. Okay. Oh no, backwards, right? Okay. So so what this means is that if you actually had the formula for the function, all right, you would know that h of -2 is equal to 7. Okay. All right. Because that point is contained on the graph. Okay. So that's just, you know, basic fact about function there, right? Okay. But the tangent line also passes through the point 7, 3. Okay, so the tangent line, not necessarily the curve itself, probably not the curve itself, right? But the tangent line also passes through the point 7, 3. Okay, and they want you to find here h of -2 and h of prime of -2. Okay, so let's make sure that we have that second point written down, right? Okay, which is 7, 3. All right. Okay, so the tangent line passes through the point 7, 3, and we know that the curve itself passes through the point -2, 7, which means h of -2 is equal to 7, right? Okay, and then we want to answer those two questions about that function. So what they wanted, the first question is, what is h of -2? Okay, so we've already answered that, right? Because the function passes through the point -2, 7, we know that h of -2 is equal to 7. So that's just kind of a gimme, right? Okay, so you don't want to miss a simple problem like that. Actually, there is a problem like that on the practice test. It's number 3. Okay, just a very basic question about function notation. All right. But the tangent line also goes through the point 7, 3, and we want to use that information to figure out what h prime of -2 is equal to, right? Okay, so there's the big question there, okay? We know that h of -2 must be 7 because of this point, but what about the instantaneous rate of change at -2, right? Or the slope of the function h at -2, right? Okay, or the derivative of h at -2. Remember, all those terms are interchangeable, all right? What must that be equal if we know this information? Well, this is where we use one of those basic facts about tangent lines, right? We know that the rate of change is the same as the slope of the tangent line, okay? So if you can calculate the slope of the tangent line, then you know what the rate of change is, right? So this question is just that simple. So when you first read that and you don't see the picture drawn for you, it may look like they're throwing you for a loop, right? Okay, they're not giving you enough information, but in fact they're giving you plenty of information. They just haven't drawn the picture here, right? Okay, so to find h prime of -2, all we have to do is calculate the slope of the tangent line, right? And remember, the reason this is true, the reason that the slope of the tangent line is the same as the instantaneous rate of change is, remember, what is the tangent line? That is the line you're going to see, right, when you zoom in on the graph of h right at this point. So if we had the graph of h, right, and we zoomed in on that, we don't have it, but if we had the graph of h and we zoomed in on it right at that input minus 2, in other words, right around this point, right, we would, the graph would start looking like a straight line, and that straight line is actually the same as the tangent line, okay, right? So if we know the slope of the tangent line, we'll know the instantaneous rate of change. All right, so all we have to do is calculate the slope of the tangent line. So we just have to know the slope formula. So what's the slope formula again? Remember, what do you do? Remember, that is, so this is one thing you might want to write down on your index card, right? Okay. You could also express it this way: h of x2 minus h of x1. Since the name of the function is h, you might want to write it down as h of x2 minus h of x1. H of x2, we can call that y2, and h of x1, we can call that y1, right? Okay, so we've used that formula now dozens of times, right? That's the average rate of change formula, but for a line, that's the same as the slope, okay? And since tangent lines are lines, we're just using the average rate of change formula, same as the slope formula, right, in order to calculate the slope. So what is y2? Doesn't matter which one of these 2 points you call x1, y1, and which one of these 2 points you call x2, y2. I'm going to use, let's use this as x2, y2, okay? So x2 is 7, and y2, I'm going to write that down as 3, okay? And then for x1 and y1, let's use this point. So I have what? Minus a minus 2, and then 3 minus 7. Okay? So did I fill that in there correct? Hope so. Okay? And so we get there what? Minus 4 in the top, and in the bottom, this is going to be 7 plus 2, which is 9. So it looks like the slope of the tangent line is minus 4/9. All right? And there it is. So that is what the value for h prime of minus 2 is. Okay? So remember, in function notation, this the name of the function with the input. That means the matching output. The name of the function with the apostrophe in the input, that means the instantaneous rate of change, okay, which is the same as the slope of the tangent line. All right? Let's see if we got that one right there. So let's see, h of minus 2 there is 7, okay? And then let's enter this one, which is what, minus 4/9, okay? If I do it like this, will it enter it correctly? All right. Or was I supposed to type in the fraction? Guess we'll find out. Okay, right. So, see, that one's pretty easy to get credit for. Okay. Now, the next two problems are really sort of the same problem. Okay. The next two problems are really this one I got wrong on my first try at this. Okay. The next two problems are really the same problem. Okay, but just elevated a little bit. All right. So here they're telling you, okay, there you've got a curve. Okay. So this is the graph of f of x equal 2x squared. All right. So that's the graph of f of x equal 2x squared, and they have drawn for you here a couple of tangent lines to that curve. Okay. One of them at this point. Okay, so we have a tangent line drawn right there at that point, and then another one over here at this point. Okay, and we want to find the equations for the equations for those two tangent lines. Okay, so we want to find the equations for those two tangent lines. Okay. Right, so the equation for a line is going to involve the slope of the line. The equation for a line is going to involve the slope of the line, but it also involves a little bit more, right? So this question is a little bit tougher than number 8, okay? Because not only do we have to calculate the slope of the tangent line, but we also have to then be able to write down the formula for the tangent line. So on the test, on the practice test, I don't think I gave you an example of actually writing down the formula for a tangent line, but you are asked in a few instances to calculate the slope of the tangent line, okay? So this is probably a little bit harder that's going to be on the test, but it is in the homework, so you're going to have to get it right here at least, right? Let's try the line with positive slope, okay, for no good reason, all right, other than that's just the one I want to do, okay? And the line with negative slope is going to be the same, okay? I mean, you're going to follow the same process, right? Okay? So to find the slope of a line, what do you need? You have to know 2 points on the line, right? So we've got to be able to identify 2 points on this line. That's what's ugly here, because that line, that graph is not really hard to read, okay? If you blow up the screen a little bit, you can read it a little bit more easily. Or if you squint, right? So one of the points is pretty obvious. It's -1, -6. That one they tell you, right? Okay? That point is on this tangent. It's also on this tangent line, but it also happens to be on this tangent line. But since this blue line is a tangent line, right? Okay, it's going to touch the graph right here at this point, correct? So if we can figure out what that point is, then we've got 2 points, right? So you have to kind of squint there. This is 0, this is 2, so it looks like the x-coordinate of that point is 1, okay? And if you read the tick marks here off on the x-axis very carefully, you can see this is 1, 2, 3, 4, 5. So this y-coordinate of this point is 2, all right? Okay? So that would be your best guess there, and that is in fact correct, right? Okay? So let me... So this is number 8. So number 10, it looks like the 2 points there that we've got were -1, -6. Oops. -1, -6. Those were the points that were definitely given to us, right? Okay. -1, -6. And then the other point that we had to kind of work at there was the point on the actual graph of the function f. That was 1, 2. Okay. So there are the 2 points on the tangent line. So the slope of the tangent line, let me, so I don't have to write out the words here, let me use our favorite variable for slope, which is m, okay? That's a famous mathematical question, is how has m come to represent slope? Because it is almost always represented by the letter m. No one actually knows that, okay, why that's the case. But it's thought that it is it's derived from the French word monter, which means to climb, okay? And so apparently a French mathematician, perhaps Descartes, adopted that letter, okay, to represent the slope, okay, using the French word for climb, all right? But that's all speculation. No one really knows for sure, all right? So now let's use our slope formula, right? Okay, so let's plug in our y coordinates, right? So I'm going to take 2 minus a -6. Oops. 2 minus a -6. Or I could also do -6 minus 2. It doesn't matter the order there. But make sure now you subtract the x coordinates in the same order. So this would be 1 minus a -1. I'm really writing stuff down wrong today. Okay. All right, so I do that right. 2 minus a -6, and then 1 minus a -1. And now let's do the simplifying here. So this is going to be 2 plus 6 in the numerator divided by 1 plus 1 in the denominator. So that looks like 8 over 2. And there's a nice slope there. So we come up with the slope of that second tangent line there as 4. Okay, right? So the slope is 4, so I know the slope, but that's not quite what the question was, right? The question was, what is the formula for the tangent line? So I've got to be able to write down the formula, okay? Well, here, once you've got the slope of a line, and you know any point whatsoever that the line passes through, we happen to know 2 points that this line passes through, right? Because we had to use those to calculate the slope. So once you know the slope of a line and a point that the line passes through, then you're in great shape for writing down the formula, because you can use what's known as the point slope formula to write down the formula. So let me remind you of that. Here's the point slope formula. Okay? It looks like this. And the x and the y are the variables in the formula. The m is the slope, of course, and the x1, y1, those are the coordinates for the point that you know on the line. So let's fill that in. So we have y minus, let's use this point as our point that I'm going to fill in for x1 and y1, but you could also use this point, okay, if you want to. So y minus 1 is equal to that slope, which is 4 times, I'm sorry, I did that backwards. Keep making that same mistake. I did that mistake. That was a mistake I made earlier. Y minus 2, that's the y coordinate, right, of the point, is equal to 4 times x minus the x coordinate of the point that we know. Okay? And there it is. There's the formula for your line. We have to simplify it a little bit to type it into WebAssign on a test, though. That I would probably be happy to see that. So we're going to have what? Y is equal to 4 times x minus 4. I'm multiplying the 4 times the x minus 1. And then I'm going to shift the minus 2 back over to the right-hand side, so that becomes a plus 2. So we end up here with y is equal to 4x minus 2. So there is the formula for our line, the way WebAssign wants to see it. Okay? 4x minus 2, that's what we're supposed to type in for our answer. We could have also plugged in, we could have used this point. You could have written y minus a minus 1, I'm sorry, y minus a minus 6 is equal to 4 times x minus a minus 1. And when you simplify that, you also would have come up with 4x minus 2. Okay, you can try that to see that. Okay, so there it is. So looks like a, ugly question, but really it's just a question about formulas for straight lines. That's really all it was. Okay? So really all this business about tangency and all these curves drawn there, all that was just kind of superficial to the problem. This is really a question about, how do you write down the formula for a straight line if you know 2 points, okay? And we knew 2 points, right? Okay, so there's the answer. All right, so I'm not going to submit that and waste time submitting that. But that's correct, I'm sure, okay? So your version of the problem might be slightly different in your homework. When you go about now calculating the formula for this line, right, computing the formula for this line, you're going to go through the same process, right? You've got to calculate the slope and then fill those into that point slope formula that I showed you, and you'll get the answer right as well. So keep this in mind, okay? That is one way of writing down the formula for a line. Okay, if you know, again, the slope, that's always crucial, and a point that is on the line. Okay. All right. More questions about that homework while we've got it up? Quick questions? Number which one? Is that like one I've just done? No? Okay. Oh boy. All right. All right, so in 1960 it says the birth weight for women in this age bracket was 59.9, and then by 2006, okay, it had gone to 41.9, okay, all right. So it had decreased quite a bit, right, okay, which, may be a good thing, but it may just mean that women are marrying later, okay? than they were in 1960. All right. So, all right. So first there it says calculate the rate of change, right, for the birth rate, assuming that the birth rate decreased at a constant rate, okay, assuming that the birth rate decreased at a constant rate, all right. So this is really an average rate of change question, all right, but because they tell you that that rate is steady, okay, then they can sort of drop the term average rate of change and just use their rate of change. So if you were to make a graph of this birth rate, okay, right, if you were to make a graph of this birth rate, okay, then what is that graph going to look like? What sort of curve are you going to get? What now? Yeah, well, the slope is going to be negative, okay, right, because the birth rate is decreasing, right, the birth rate is decreasing. But what's more important is they're telling you that that birth rate in this one, they're telling you to assume that that birth rate is decreasing at a constant rate, right, okay, at a steady rate. So that tells you more about the shape of the curve. That actually tells you the curve is going to come out looking like a what? A line, exactly right. That's the crucial thing there. So this also is really a question about straight lines, okay? So when you read that, you know, it looks like, who knows, right, okay, what that is about. But really, that's a question about straight lines. And what they have given you here are 2 points on that line, okay? So when they ask you to write down the formula, for this function, okay, which outputs the birth rate, right, you're going to get a linear function formula. You're going to get a linear function formula here, okay? So you really need to key into that piece of information there, okay? All right, so actually let's try doing this not sequentially here, but I'm just going to sort of do this all at once, okay? Because I've already realized here now that what we're talking about here is really just a straight line, okay? All right, so let's actually write down the formula for the line, and as part of writing down the formula, we'll answer part A, and we'll also be able then to answer part C from that formula, okay? By the way, notice here in your formula, X is going to be elapsed time, okay? So X is going to be the number of years since 1960. I'm so glad, because otherwise we would be dealing with a big value for X, right? Okay, but now we don't have to deal with a big value for X because X is going to be elapsed time, right? Okay, so keep those numbers in mind for me, because I'm going to switch back here so we can write this down in our notes. So what are the 2 points that are on that, so this is problem number 5. What are the 2 points that are on that line, okay? So what was the first point that was really given to us? So that corresponds to the birth rate in 1960, okay? So what was that birth rate? 59.9, right? So see, that's what we're going to write down for the y coordinate of this point, okay? But what are we going to write down for the x coordinate? Not 1960. 0, right, because remember, our x values are going to be elapsed years from 1960, okay? So you could do the problem filling in 1960 here for this point. You would just get uglier values, okay, right? And then, what's the second point? Well, that is the point that corresponds to that second piece of information they gave us, which was the birth rate in 2006. So 2006 in elapsed years is going to be what? 46, right? And what was the birth rate in 2006 for women in that age group? 41.9. So see, there are the 2 points on the line, you see, okay? And now we just have to calculate the slope. That's that rate of change that they're asking in part A. That's the same as the slope, all right? So you get there, doesn't matter how you do the arithmetic, right? So let's do 41.9 minus 59.9 for our numerator. So I'm taking the difference in the y coordinates, right, divided by the difference in the x coordinates, and we are going to come out with, messy numbers here, okay? But and then we're going to have to round to some decimal places, right? So in the numerator, that's going to be minus 18. Is that correct? Am I doing that right? Okay. And in the denominator, even I can do that. That's 46, right? Okay. And so to 3 decimal places there, what's 18 over 46? 391? 391, okay. And is that rounded properly? Okay, all right. So minus 0.391, okay. So there is the slope, all right. And now we want to write down the formula for the line, okay. So to 3 decimal places, there is the slope. So I think that's the answer to part A. That was the rate of change, minus 0.391, okay. All right, and all right, so now what's the formula for the line? Well, now let's go back to using that formula that I just gave you here, right? Okay. See, if you know the slope, which we now know, right, and you know any point on the line, then you can fill in those values into this equation, and you can write down the formula for that line, okay? So let's use that first point because that makes the arithmetic really easy. We just have y minus 0 because, y minus 59.9. I keep reversing x and y today. That's the same mistake that I always complain about with my students, all right? So y minus 59.9 is equal to that slope, which is minus 0.391 times x minus 0, okay? So that's really easy. X minus 0 is just x, right? And now you can also bring the minus 59.9 over to the right-hand side. So you end up with minus 0.391 times x plus 59.9. So there is your formula for your function. Now, they didn't call the left-hand side y. Remember, they used function notation, so they called that b of x. I guess b for burst there, right? Okay, so they put b of x, but b of x is the same as y, all right? B of x is the output, okay? So that's the same as the output y, and then there's the formula that you're going to type in there, minus 0.391 times x plus 59.9, okay? So when you see that rate of change is steady, rate of change is steady, then that's a real clue there that, we really got a pretty easy problem here. This is just a straight line, okay? And straight lines, those are the easiest types of functions of all to deal with, right? That is one of the key driving ideas behind calculus, right? It would be nice if all functions were straight lines, right? Because straight lines are so easy to work with, okay? So what calculus tries to do, of course, is turn every function into a straight line, okay? By zooming in on this tiny little pieces of the graph, right? So tiny little pieces of the graph will look like straight lines, right? Okay. So I'm not going to fill those in and check those, but I think I got that right, okay? All right. Oh, one more part there, the part C. That's actually the part you were asking about, right? Okay. So estimate the birth rate for women in 2015, okay? Well, now that we have this formula, right, we're in great shape. All we have to do is plug in the right value for x, right, into our formula, and then do a little bit of arithmetic. What's the right value for x? So 2015 corresponds to how many elapsed years from 1960? 55, right? So to answer that part C, you're just going to plug in 55 there for x, and then carry out the arithmetic with your calculator. So this is one reason why a calculator is going to be so helpful to you, right? Okay, so you can do arithmetic like that one. Yeah. because they wanted the birth rate in they wanted us to estimate the birth rate in 2015. Okay, remember they only had data from 1960 and 2006, but they wanted that data to estimate the birth rate in 2015. Okay, and so we have to fill into our formula here a correct value for x. Well, 2015 is 55 elapsed years from 1960. Okay, right? Okay, so that's where the 55 came from. So keep in mind, the value that we come up with for the birth rate, our estimate for the birth rate, is only going to be an estimate. Okay, and it's an estimate assuming that the birth rate is going to continue to decline at a steady rate. Okay, after 2006. Maybe that didn't happen. All right, so maybe our estimate is incorrect. Okay, but at least we have a reasonable estimate here, right? Okay, great. So now let's look over and let's go over now some problems from the practice test. Okay, my favorite problems from the practice test here. All right. So John, did you get a chance to pass out some of those or so? Oh, okay. So you're going to have to share. So for those people that don't have the practice test, I'm going to display it here, but you'll have to share. So so we'll see it up here, but if you want to be watching there on your desk. First one I'm going to look at is problem 4, part L. Okay, and that problem 4, part L refers to this graph. Okay, this graph in problem number 4. And there are lots of questions about that that particular function graph there, which is called f. And so when you see the answers to the practice test, you will see all these filled in because they all refer to this graph. But most of those are pretty straightforward questions, so I'm not going to go through those. Okay, we've done lots like that. I want to look instead down here to the last two here, which are 9 and 10 from this big list of expressions. Okay, 9 and 10 from this big list of expressions, and these are just true-false questions. Okay, these are just true-false questions. So it's asking you first, is f of minus 4 greater than f of minus 1? F of minus 4, is f of minus 4 greater than f of minus 1? So we have to go, we don't have the formula here, so we can't calculate these, right? So we have to just go back and look. F of minus 4, is that bigger than f of minus 1? Well, let's see. Where is f of minus 4? That's up here, right? So there's f of minus 4. Y'all agree with that? That's f of minus 4. And where's f of minus 1? There is f of minus 1 right there. Okay, so here's f of 4. Looks like it's about 5, right? And there's f of minus 1. Looks like it's about 2. But we really don't care exactly what the values are, right? We just want to know, is f of minus 4 bigger than f of minus 1? Is that true or is that false? It's true, isn't it? Right? Okay. There's f of minus 4, right? Okay. Which is way up here. Here's f of minus 1, which is way down here. So I think it's true, right? F of minus 4 is bigger than f of minus 1. The question wasn't, is minus 4 bigger than minus 1? Which is false, right? It was, is f of minus 4 bigger than f of minus 1? Okay. And I think that indeed is true, right? Okay. So, so see, the answer to that one is, that one's pretty straightforward, I hope. Okay. That one is true. All right. Now, it's the second part of that that's the tricky part, okay? Because here they're asking, is f prime of minus 4 bigger than f prime of minus 1? So, see, when we throw the prime in, remember, that means instantaneous rate of change, right? This is just the output. This is the instantaneous rate of change. And so keep in mind, the answer here may have nothing to do with the answer here, right? F of 4 and F of minus 4 and F prime of minus 4, they can be completely, totally unrelated to each other. F of minus 1 and F prime of minus 1, they can be completely unrelated to each other. Right? They can have totally, wildly different values, okay? So just because this one is true doesn't mean this one is true, doesn't mean it's false, but it doesn't mean it's true, okay? So we have to go back and look at the graph again at minus 4 and minus 1 and see if we can answer that part 10. So remember, the rate of change refers to the slope of the what? Yeah, what kind of line? Tangent line, right, okay, refers to the slope of the tangent line, right. So let's just really quickly here, just very roughly, sketch in a tangent line at these 2 points. So that's not bad, right? Okay, so there's the tangent line at minus 4, and the tangent line is at minus 1 is really hard to draw because it's very similar to the graph, okay, but I think it looks something like this. This is an odd instance where the tangent line cuts through the graph. Okay, mostly tangent lines will not cut through graphs, but there's no way to draw a tangent line here without having it cut through the graph. Okay, and so what's the answer there? What about the slope of this tangent line? We don't know its value, and we don't have to calculate it, but we do know is it positive or is it negative? Positive, because that tangent line is going up, right? What about this tangent line? Yeah, its slope is going to be negative, right? Okay, so we know f prime of minus 4 is going to be positive, and f prime of minus 1 is going to be negative, because this slope is positive and this slope is negative. So that's all I need, right? I don't need to know the exact values, right? I know this one must be positive, and this one must be negative, right? I don't know how big a positive number this one is. I don't know how small a negative number when this one is, but this one's positive and this one's negative. So what about that whole expression? True or false? True, right. Must be true, right. Yeah, positive numbers are always bigger than negative numbers. So this all is true, okay? It turns out that, yes, f prime of minus 4 is bigger than f prime of minus 1. So watch out on the test, right, between function outputs and instantaneous rates of change, okay? And to answer a question like this, you don't have to try to, figure out what the slope of that tangent line is, right? It's just enough to know, yeah, this one has a positive slope, this one has negative slope, and so I know that expression must be true, right? Okay, so that was the first one I wanted to look at. All right, now let's go on to, this is not a calculus question, but I know this one, if we have one like this one on the test, this one's going to throw you off, okay? So this is 5C, all right, number 5C. So first it says, here's a function formula, S of t is equal to 2t plus 4 over t squared minus t. 2t plus 4 over t squared minus t. So I'm using t as the variable here, not x. All right, and we want to calculate s of t plus h. S of t plus h, right? So students always hate this. We have to evaluate that function at a symbolic input. But it's so easy. You just take the t plus h and you plug it into the formula wherever you see t, right? So I'm going to plug t plus h into the top. So I'll have 2 times t plus h plus 4. And then I have to plug it into the bottom. So I'll have t plus h squared minus, and be careful about this, t plus h. You're going to plug in for that second t, the whole expression, t plus h, you're going to plug in for that, right? So see, everywhere in the formula where I saw t, I'll substitute t plus h. And now I just have to do a little bit of algebraic simplification here. The top is easy because you just multiply the 2 times the t plus h. So you get 2t plus 2h plus 4. That's easy. The bottom's a little bit harder because you have to square t plus h. And I know you're going to want to write down t squared plus h squared. And please don't do that, okay? So on your index card, remind yourself, if I'm squaring t plus h, that means I have to multiply it by itself. It's not just as easy as squaring the t and squaring the h. Now, the minus t plus h is pretty easy. You can just distribute the minus sign, so you get a minus t and a minus h. Okay? Minus times the t here is minus t, minus times the h is minus h. Now I have to finish that multiplying the t plus h times itself. Well, how do you square this binomial? You take t times t, that's t squared. You take t times h, see, t times h. So I'm going to write that as ht. I always like to write the variables in alphabetical order. Just have a fetish about that. Okay? And then we have h times t, this h times this t. So that's ht again. And then we have h times h. So that is h squared. So you do get t squared and h squared, but remember you also get that middle term. And don't drop off the minus t times the minus h, because you're subtracting the entire quantity t plus h here. When we substituted t plus h for t, we have to put it in parentheses. So you're subtracting both the t and the h. Okay, so that will give you minus t minus h when you drop the parentheses. So I have 2t in the top plus 2h plus 4. And then in the bottom, just add your like terms. So you have t squared, and then you have these 2ht terms. So that's 2ht plus h squared minus t minus h, and that's it. There's no more algebraic simplification you can do there. There aren't any more like terms in the, none of these are like terms in the denominator. None of these are like terms in the numerator. So that's it. You're done. Okay? So you end up with an ugly answer, but that's it. Okay? So that's about as bad as the algebra will get on the test. Okay? That's actually, well, no. I was going to say that's about as bad as the algebra gets in the class, but that's not quite true. Okay? Now, what about the domain of this function? Remember, domain, you cannot divide by 0, right? Okay, so normally I think for this first question and not for this question, for the first question here in this, for the first part of this question, the domain was all real numbers. But here the domain is not going to be all real numbers because you have to be careful to not divide by 0. So you can't plug in a value for t into this formula that will cause you to divide by 0. So you need to think about, okay, what's going to cause me to divide by 0? Because I cannot have that in the domain. So just take the denominator, t squared minus t, and set it equal to 0. Just figure it out. Set that denominator to 0 and figure out what values for t are going to make the denominator 0. In other words, solve that equation. That equation is a quadratic equation because we have the unknown squared here, but you can solve that one by factoring because that one factors so nicely because you can factor out a t. So you get t times t minus 1 is equal to 0, and that means either t is equal to 0 or t minus 1 is equal to 0. Well, so there's one value you can't plug in for t. You cannot plug in 0. And what's the second value you cannot plug in for t? From this equation, what is that equation telling you? 1, right? If t is 1, you're also going to get this to be 0. So those are the two things you cannot have in your domain. So I would write the domain as, the easy way to write this is in words, all real numbers except t equals 0 and t equals 1. Okay? Yeah, when you solve that equation, you get t equals 1. So there are the two exceptions that you cannot have in your domain. Okay. This problem is also a very similar problem. There you have a function x minus 2 to the minus 3 power. So what does it mean to raise a quantity to the minus 3 power? We talked about this in class. What do negative exponents tell you to do? Take the fraction, right. So this is the same as 1 over x minus 2 cubed. And now when you've got it written this way, it's so easy to see what the domain is. What can you not plug in for x here? So you don't want to divide by 0, right? So what can you not plug in for x? 2, right. If you plug 2 in for x, you're going to have 2 minus 2 cubed. That is 0, okay? So, that one's so simple when we remember what that minus 3 power means. So the domain here is all real numbers except 2. Okay. So I know those are going to be bugaboos for you. Watch out for that if that shows up on the test. Okay. All right, now let's look at number 7. Okay. So there's number 7. Here we're given a function, and we're asked to find change and percent change, okay, and so forth. So you got to remember how to calculate change and percent change from a function. All right. So what's the change formula for a function? Remember, it's f of the second input, right, minus f of the first input. That's the formula for change, right? So what's the x2 here? The x2 is 4, and the x2 is, the x1 is 2. So the change is just going to be f of 4 minus f of 2. Well, when you plug 4 into this formula, I'm not going to actually show you the arithmetic here, but it's easy. When you plug 4 into the formula, you'll get 0. You plug 4 in there, you're going to get 0. When you plug 2 in here, you're going to get 140. So you end up with 0 minus 140, which is minus 140. Okay? So what's that? So there's the change, okay, minus 140. So what's that change telling us? That change is telling us what? From, be sure to put the from in there, from x equal 2 to x equal 4. That really means from the second year to the fourth year, but I'll let you write it down as from x equal 2 to x equal 4. X here is measuring years, by the way. Okay. So from x equal 2 to x equal 4, what happened? The output value, what's the output value from this function? What does it tell you that the output value here is? What's the y value here? What does it tell you in the problem? Can y'all read that? Yeah, okay. So the resale value decreases, right, because this is a negative change, right? So the resale value decreases, and what's the output measured in? What's the resale value measured in? Must be what? What? Sure, it's got to be dollars, right? Okay, I don't know if it says it there. Okay, so the resale value decreased by $140. Okay, that's just change. What? No, you don't have to do a per here because this is just change. Okay, so this is an average change or a percent change. This is just plain old change. The next one is percent change, though. So make sure you know how to calculate percent change, right, from a function. So remember, that's f of x2 minus f of x1 divided by f of x1. All right, times 100%. That's that percent change for a function formula. See, this is last minus first divided by first. This is the last output minus the first output divided by the first output. That's the first output times 100%. Okay? So we figured out that f of x2 a minute ago was 0. And f of x1, we figured out, that's f of 2. We figured out that was 140. So we have 0 minus 140. That's really just the change. See, we just calculated that a moment ago. In percent change, you use the change, right? So we're going to write down that minus 140 again. Okay, that's the change. And then times f of x1. So f of x1, that was the 140. Okay. Times 100%. Let me fill in what this is. This is f of 4 minus f of 2 over f of 2 times 100%. So you end up there with minus 140 over 140. I think that's going to be negative 1, isn't it? Times 100% is minus 100%, right? So what's the interpretation there? Okay, still no per in the interpretation because this is percent change. So you just say what? From x2, from x equal 2 to x equal 4, the resale value decreased by 100%, right? Yeah, the resale value decreased by 100%. Okay. So it's interpreting the percent change is almost the same as interpreting the change, except you have to put that percent, right? Okay. So in the answer key, you'll see that. Now, this is a linear function, though. This is a linear function, right? Okay, because notice your input variable is just raised to the first power. So this is a linear function, so it has a slope. So here they're asking you for what's the slope of the line, and then to interpret that, okay? Well, what is the slope of that line? You can read that off of the formula now. So you don't have to find 2 points on this line to read the slope. What's the slope of that line? Minus 70, right, yeah, okay. That's the coefficient of the x there. So that one's so easy because we've got the formula, so we can just read the slope. Now we want to write down the interpretation. Remember, slope is a rate of change, though. So here you are going to have the per, okay? Here you are going to have the per, okay? But because for a straight line, this is important, for a straight line, slope is steady. Slope is steady, so you don't have to put from to, okay, because it's always the same. So here we don't have to put from x equal 2 to x equal 4, or from x equal whatever to x equal whatever. We can just say flat out what? The resale value, right? That's the output here. That's the y. The resale value is, what's it doing? Decreasing, right. So the resale value is decreasing by, and this is dollars, right, by 70. Now you do want to put your per, right? Well, we know the x is years, so the resale value is decreasing by $70 per year, okay? Now, this one is super easy now because now they're asking us for an instantaneous rate of change, right? But this is a straight line, right? So for a straight line, the instantaneous rate of change is just the rate of change, okay? Because for a straight line, rate of change is always the same. So f prime of 2 is going to be what? Negative. It's going to be the same, right? Okay. Yeah, okay. F prime of 2 is also going to be minus 70. See, that's the whole point of lines and tangent lines, right? Okay. Rate of change for a line is steady, okay? So it didn't matter here if you had f prime of 1 or f prime of 0 or f prime of 3 or f prime of 4. You would always come up with the same thing, minus 70, okay? Straight lines always have the same rate of change. It doesn't matter at what input you calculate it. And the interpretation is the same as the interpretation of the slope, okay? The resale value is decreasing by $70 per year, okay? That's happening after 2 years, that's happening after 1 year, that's happening after 3 years, that's happening after 4 years. That's just what is happening to this, the resale value of this cell phone, okay? The rate of change is steady, okay? All right. Now, let's look at one, though, not a not a straight line, right? Okay, so for straight lines, that's so easy a question, but let's look at one not a straight line. Okay, so this question really kind of condenses everything into one problem. So getting through problem number 9, really helpful. All right. So that's not a straight line anymore, right? So now things like average rate of change and instantaneous rate of change, right? They start having some real meaning because the average rate of change will change at different places. The instantaneous rate of change will change at different places, right? Okay, because this curve wiggles, right? Not a straight line any longer. So let's find the average rate of change from m equals 0 to m equals 6. Okay, what this curve is showing you is we have an acre of land, and we are applying an experimental pesticide to the land. Okay, and we're going to measure the population of insects there on that acre of land, right? Okay, because we're trying to get an idea of how good this pesticide is. So the curve there, the output shows you the population of the insects in thousands, right? Okay, on this acre of land. And so you see after you apply the pesticide is working, so the population is going down. But then at some point, right, the pesticide wears off, and so the insects population starts going back up again, right? Okay, so that's what's happening in that curve. All right, so let's find the average rate of change of P. That's the pest population, because that's what this curve is showing here, right? From m equals 0 to m equals 6, right? So what is that average rate of change formula? You can write it down as, let's write it down using function notation. So that's going to be P of 6, that's the last value, minus P of 0, that would be the first value, right? Divided by, this is not percent change now, so if this were percent change, we would divide this by P of 0, right? Okay, but this is average rate of change, so we divide this by the length of the interval, right, which is 6 minus 0. Okay, remember average rate of change formula and the slope formula are the same. Okay, so P of 6 minus P of 0 over 6 minus 0. So let's see, we got to figure out now what P of 6 is and what P of 0 is, so we got to have to write down some estimates here. It looks like P of 6, that one's pretty easy. That one, 13, right, so that one is that's a no-brainer. But P of 0, we have to give an estimate for, I think that's maybe 17.3. So you just write down your best estimate there, okay, divided by 6, right? So you end up with minus 4.3 divided by 6. And a couple of decimal places on the test is probably sufficient. So what is that? Minus 0 point something. Minus 0.72, okay, if I round off to a couple of decimal places. Okay, so minus 0.72, right? Okay, so there's our average rate of change. Remember, that is the same as the slope of the secant line that connects these two points on the graph, okay? So that minus 0.72 is the slope of that secant line that connects those 2 points on the graph, okay? Now, what's our interpretation of this? This is an average rate of change, so the interpretation is going to involve a per, and you're going to have to be careful now to say when you are talking about, because the average rate of change for this curve, not steady. So you have to say from m equals 0 to m equals 6. In everyday conversation, you would probably not say from m equals 0 to m equals 6. You would probably say for the first 6 months, right? Okay, for the first 6 months. But this is fine. You can write down from m equals 0 to m equals 6. The output, what's the output here? That's the pest population. So don't say the y value. Tell me what the y value is measuring. It's the pest population. Did it go up or did it go down? Yeah, sure, it decreased, right? So it decreased by, Now convert this back to the right units of measure. So don't write the pest population went down by minus 0.72, because that's a pretty depressing thing for the pesticide, right? That means you didn't even kill one insect, right? Okay, but it actually went down by minus 0.72 thousands, which is 720. All right, okay. So I'm going to convert that back to thousands, or you could put my 0.72 thousand. I could live with that also. Okay, and now you've got to have the per though, right? Because this is an average, and how are we measuring time in this problem? Months, right? So it went down 720 per month. Now that's only what happened on average, right? Okay, that's not what happened every single month. If that rate of change were steady, the curve would have looked like this secant line, but it doesn't look like this secant line. Actually, at first the population was dropping fairly rapidly, and then when we get over to 6 months, right, it doesn't drop as much anymore, right? Okay, when the pesticide starts to wear off. You see, okay? So that's only what happened on average. That's not what happened every single month. All right, so G is very similar. You're going to calculate the average rate of change there in the same way. This is a trick question, H, because I have from m equal 5 to m equal 9. Why is that a trick question? Yeah, 9's not part of this curve, right? The domain stops at 8. So that part H is undefined, you see, okay? I was trying to trick you there, okay? You can't calculate this average rate of change, right? Okay? Now let's move on to finally where we're doing some calculus, instantaneous rate of change, right? Okay? So it says sketch the tangent line to the graph at m equals 5. Sketch the tangent line at m equals 5. So let me erase this secant line because that's going to get in my way. And let me see if I can sketch in a tangent line here. May not do it very well freehand here. At m equals 5. Yeah, I can live with that. Okay. So there's my tangent line, pretty close, okay? May have gotten it off by a little bit there, but by hand, not too bad. So that's what you're going to be doing on your test, is trying to, draw this secant line, okay? Might be good if you brought a straight edge with you here to help you with this, okay? If you want to get a much better estimate. So there's the tangent line, right? Okay, so I've drawn that in, and now we want to estimate the slope of that tangent line. So I've got to find 2 points on the tangent line. Don't put them on the curve, right? They've got to be on the tangent line. Well, here is 1 point on the tangent line. It's also on the curve because that's where the tangent line hits the curve, right? So that is 5, and I'm going to say 13.2. All right. So 5 and 13.2, and then another point on this tangent line. How about that point? I like that one. Okay, because that looks like 8, and don't say 0, because what is this on the y-axis? 12, yeah. All right, that is not the origin. Okay, that is 0 and 12. All right, but I think that point is also on my tangent line, way off the curve, but it's on the tangent line, and now we can use that point to estimate our slope of that tangent line, okay? Well, let me calculate it up here while I've got it. So the slope of the tangent line is going to be, right, 12 minus 13.2 over 8 minus 5. Ooh, I got really nice numbers here because this is minus 1.2 over 3, which is minus 0.4. Is that right? Wow. Okay, it came out so nicely there. All right. Yeah, I'll know if you did it right. Okay, so if you wrote minus 0.42 or minus 0.45, or you can even be off by more than that, I can see if you drew the tangent line, a reasonable tangent line, if you pick points off of your tangent line, if you calculate the slope correctly, right? Okay, so everyone is not going to get the same answer. We're doing estimates. What we're moving toward, though, is everyone getting the same answer, right? Okay, because we don't want now everyone for the rest of the course coming up with different answers, because that will drive all of us crazy, right? Okay, so we're going to eventually learn how to do this precisely so that we all get the same answer. So the slope of the tangent line there, I think, is minus 0.4, which is the same as the instantaneous rate of change. So these two answers are exactly the same, and this answer is exactly the same. Isn't that nice? Okay. Because those are all the same thing, right? Slope of the tangent line, same as the instantaneous rate of change at the input 5, because that's where I drew the tangent line, same as p prime of 5. So once you've got one of those answers, there's the cascade, okay? All right, now, let's look at the last one here, and we're just about out of time. So suppose you are given... You're just told that p prime, not p, but p prime of 7 is 0.7. What does that mean in the problem context? Okay, so what's our interpretation? So remember, this is a rate of change. Okay, this is a rate of change. So your interpretation is going to look like interpretation of rate of change. So it's going to look like interpretation of slope, interpretation of average rate of change, not percent change or change, right? But it's going to look like an interpretation of a slope or a rate of change, right? Okay? But it's instantaneous rate of change, not average rate of change. So you would say here at m equals 7, okay? So you don't have to say from, m equals something to m equals something else, right? Okay, because this means right at the input 7, what is the rate of change? Okay, so at m equals 7, probably you would say that after 7 months, right, instead of saying at m equals 7, but you can write down at m equals 7. I'll accept that, right? The output, what's the output again? What are we measuring here? The pest, right, okay? So the pest population, yeah, we're measuring a rate of change, but that rate of change refers to the pest population. The pest population, is it, according to this, going up or going down? It's up, right, yeah. Okay, see, remember, this is after 7 months, right? This is not in general, but this is after 7 months. So after 7 months, the pest population is increasing by, and 0.7 would be how many insects there? Yeah, 700, and then don't forget the per, right? Okay, because instantaneous and average rate of change must have the pers in there, okay? So per month. So the pest population is increasing by 700 per month, all right? I don't know if that was reasonable or not. I think I didn't give a very good idea, because there is 7, and I don't think the slope of that line is 0.7. Okay, if you kind of sketch in the tangent line here, it doesn't look like it's 0.7. So I think I overestimated there what the slope of that tangent line is. Okay, but nevertheless, the pest population is going up after 7 months, right? So we correct to have the rate of the instantaneous rate of change as increasing, right? Okay. All right. No, because this is a rate of change, okay? So it's increasing by, yeah, what is the pest population after 7 months? You know that. It's not 700, right? It was a little bit above 13,000, right? Okay, yeah, okay. Okay, so 10 to 12, right? Friday in South 405. So I'll send her an email about that too. Right, so more chance to review this practice test and other questions to get ready for the test. Okay? All right, so good luck. See y'all Monday.